There we go. Alright, so this is just question 17. I've already got it basically laid out just to save some time. So basically it's talking about how like a soccer player kicks a ball at 27 meters per second at 30-degree angle. So it's basically asking to find the like how long it's in the air for, which is just time, like the horizontal distance, which is delta x traveled by the ball, and then the maximum height, which is just delta y. So by doing that, what we should do is first we're gonna have to find like delta. We're given like the 27 meters per second as like the speed it's kicked at, so we know that that's v naught or basically v0. So by doing that, we can actually use it to find the vx and the viy. So let's just set up a little table, x, y, and let's go. So we see this at 30, 60, 90, so we can skip the cosine and the sine. So we know, so basically, so this right here, VIY, is going to equal 1/2 of the hypotenuse. So it's just going to be 13.5 meters per second. And we're also dealing with like this problem, the ball lands at the same place it was kicked. So we're going to know the, first the VIY is 13.5. And the special rule is that the VYF, which is velocity y final, is going to be negative 13.5. We just add the labels for both of these, meters per second and meters per second. So for that one, we're just going to, for the Vx, it's just the short side times rad 3. So I'll just plug this into my calculator. Let me see. So we're going to get 23.38 meters per second. So Vx equals 38. Oh, whoops, what am I doing? 23.38 m/s. And then some other things we know is the acceleration due to gravity, which is just negative 9.8 meters per second squared. And then we're also, so in this question we're looking for delta x, so that's question mark, we don't know. We also don't know the time, and that's going to be really important for solving pretty much any problem. So that's for both of them. Let's just give that t a little hook. And now, the first thing we should probably try to do is, I'd say just solve for the time. So we can use this equation, which is VF is equal to VI plus AT, and then we just substitute in. So we're going to use the y values this time since we have both these right there. I'm just going to plug it in. So negative 13.5 is equal to 13.5 plus negative 9.8 t. So now we're just gonna put this here. That's a 5, and then we're just gonna divide out by 9.8, and then we're gonna get t equals, let me just plug this in, 2.76 seconds. So with time, we can use that since we know Vx, we can simply just do Vx. So to get delta x, what we can do is we can do delta x is equal to, just like rate times time, so distance is equal to Vx times t. Now when we plug that in, delta x is equal to, let me just group that over here. Delta x is equal to 23.38 times 2.76. And for that, we're going to get, let me see. I'm going to get 64.5 meters. So now we can just put it right here. So let me grab my little eraser. Real quick, just equals 64.5 m, which is meters. So now I'm just gonna clear this work so that I can save some space for the last one. Alright, so we're just gonna set this pretty big. Yeah, I'm gonna just go like this. And we know that the time is 2.76 meters. Yeah, it's just a little bit hard, not used to this software, but we're adapting. And let's just 2.9, 2.76 s, 2.76 s. So now for the last part, we're just looking for delta y. And to do that, we can just get there's two different equations we could use. But the one I'm probably going to use is vf squared is equal to bi squared plus 2a times delta y. So we're going to get 13. Oh. Actually, you know what? Yeah, we don't even need to. I just realized while I'm doing this, we can actually use the x values for this one. Well, actually, wait. Wait, what am I going to do? Hold on. Oh, it's looking for... No, it's not looking for delta y. It's looking for max height. I was confused for a second because I just realized when we'd subtract, we'd get like 0. So, for maximum height, the velocity final is actually just going to be 0 because when an object is at its apex, like that, there's still acceleration, but there's no this is 0 velocity. So we're going to put in 0 is equal to 13.5 squared, b initial, plus 2a, plus 2 times negative 9.8 m slash s squared, and then delta y. So we're going to move this here, divide out by negative 9.8, and then, divide by, and then negative 9.8 times 2, and then we're going to get delta y is equal to, I'm going to plug this into my calculator, we're going to get, I think, yeah, it's saying about 9.3 meters. So that's all for today. That's just my physics video where it's landing at equal height, and have a great rest of your day.